All right, so this is the first chunk of stuff we want to get into. It's a great way to start talking about the things you need to for the class. So let's look at this. I have, hope for the first page, same as yours. If you zoom in on this, look at that first one. It says solve the following linear system by graphing. And whether that triggers some memory or not is not important. But I'm curious, anyone have like an instinct to start? Something they just can't help themselves to do? Okay, bring it on. Take it. Hey, I'm going to do names too. I'll remember. Okay, Tanner, you're on.
To just start it?
Yeah.
So just like do the first.
Yeah, what would you do first? And I don't expect you guys to remember, but somebody might remember something.
The first thing I do is divide y by 4.
So you're looking at that top equation, and what's your goal by doing that? Because that's a good idea.
To get it into slope-intercept form so I can
Man.
properly graph it.
That's specific. Yeah, you want to get into slope-intercept. You want to graph it.
Yeah.
And our favorite form of an equation is slope-intercept form. A whole bunch of this class is rewriting equations into forms so that we notice stuff. Like, we do that not because it's the best way to write an equation. Like, this is a perfectly good linear equation right here. That's great. But if you get y by itself, then you get it in slope-intercept form, then it makes more sense to us. It has parameters and it has a slope and a y-intercept. And so we do lots of that, figuring out ways to solve. It means your algebra skills are number one in this world. Even in calculus, the biggest issue is just making sure you have solid algebra skills. Like, you can solve for a variable at a given time and not break rules. There's a whole bunch of rules this semester we're gonna focus on the rules of algebra you cannot break, that everybody tries to. So if you divide by 4, I like this one. You divide everything by 4. And do you remember that cool process? You can divide everything by 4, but if you're going to get slope-intercept form, if you have multiple terms, you can split it up. So you actually literally divide all the terms by 4. So good memories, I'm sure. The good old days. Algebra 1. Some of you who wrote you loved algebra. Welcome aboard. This is algebra intensive. The things that jump out at you, you get your slope and your y-intercept. Remember that y-intercept is the part that's not with the x, and the slope is the part that is. The slope is the number that is attached to it. You might not realize you can detach this. Negative 3/4 times x. That's your slope right there. So when I rewrite this here in a minute, it'll be all purdy and kind of isolated. It'll be y equals 2 minus 3/4 x. That's that slope-intercept form Tanner mentioned. So hopefully a good memory. But you learned this. This is the beginning of Calc 1. You got to graph lines. You have to find their slope and y-intercept. It's just that that slope is found by something called a derivative. But we still have to use the same equation and be fluent with that part of the lingo. Next one. You want to get y by itself on that one? Oh yeah, so I'm going to go blue. Go blue, come on. That'd be y minus x equals 1. You want to remember you're doing inverse operations and solving. Like, you're looking for, the glue for the 4 on the previous problem was multiplication, so we divided. Here, it sounds trivial and simple, but as things get more complicated, you still don't break these rules. You go, yeah, I'd like y alone. This is a minus x, so I add x to both sides. You kind of have to walk yourself through that even on tougher problems, and then know where to find your stuff. The yint and the slope right there. Got it. And then you're good to go. We can graph. And then apparently, that was an instinct. Thanks, Tanner. That was a good one. We're going to graph it and then sit back like everybody does and go, now what? We look at that. I go to y-intercept of 1 with the blue graph. Got it. And then the rise up 1 over 1 for the slope. And this is purdy. Just connect the dots. Yeah, I like that one. My red one, that was remember slope and y-intercept. You start with the y-intercept, kind of a point to begin your graphing is 2. And then you go down 3 over 4. Getting excited yet? Some of you algebraticians are salivating. There it is. Ta-da! I did something. And in higher level math classes, you can learn to do something, and then you look at it and go, but what did I do? Does anyone know what we did, and what are we supposed to do again? What am I looking for? Point of intersection. And what will that point of intersection provide? The solution. What is a solution? It's what we all need, a solution to something. I need to know how to use less laundry detergent when washing clothes because it costs a small fortune to wash clothing for 6 small children. Wait, we only have 4. Where'd those other 2 come from? Weird. Yeah. So when you guys get to this, you got to find the solution. It's the X and Y. The solution is the intersection. And we actually, so if I go work at that John Deere job, that $65,000 a year, I'm 22 years old and I'm making $65,000, which is just ridiculous and awesome at the same time. And I get the job. They're probably going to give you data analytics. Everybody's got data. They always give the college kids the data, fresh out of school. They say, here's some data. I want you to fit a line to it. Cool. I've done that in school. I can Google it, figure it out. They say, find the solution, the intersection. So you do that. You graph it and you find the intersection. If you're making $65,000 a year and nobody's grading your work, you probably should go to a tool like a calculator, like this, graphing calculator. And by the way, when I go to jobs, if it's a DuPont Pioneer, or if I go to Kemin or wherever the places I go in my summer job, people have their TI calculators. I kid you not. They sit with them next to them and they do a lot of their calculations. So chemists need to do just quick formulations or do things on the side, or somebody's doing some kind of analytics and they'll use their calculator. It's fun to see that those are out there. But just your ability to use it's good. What about, does anyone know this tool? You seen that before? What do you call that? Somebody's used it before. Luke, yeah.
I don't know what we call it, but I used it in like 9th grade.
9th grade, a whole bunch of times? You just pronounce this for me. What do you say?
Desmos.
So, what is the capital of Iowa, capital city?
Des Moines.
So we live outside of our beautiful, wonderful city of Des Moines, and we call that Desmos. Do you let people call our capital Des Moines? No. That's Des Moines. We'll forever call that Des Moines. We do not pronounce our S's here in the beautiful state of Iowa. So Des Moines is a graphing calculator application. You're welcome to use it anywhere you go. There's an app for it, like there's an app for everything on your phone, which is awesome. The web browser version on your phone through Chrome or Safari works awesome. Your computer version of it works awesome. It's just a really robust, wonderful program. You can't use it on tests, and you kind of have to be careful you limit your usage. But if I were making $65,000 a year and I needed to find the intersection of lines, which is not far from an actual task that was given to a teacher one summer, and they're legit tasks. They're not shortchanging them. They need help, and you hire these teachers in the summer because they're good labor and they're inexpensive. So yeah, we work for cheap. That's what we're known for. It's kind of nice. So when I look at my graph, I'm doing 2 minus 3/4 x, and what was the other one? 1 plus x. I can do this. Okay, so 2 minus 3/4 x. Ready? 2 minus 3, 4, oops, typo, fourths x, and then 1 plus x, right? Y equals 1 plus x. Oh, wish I had the same colors as I was using. Ta-da! Look at that! And what's cool about Domomo is that it has the intersection and intercepts are like standard procedure. It just finds them whether you want them or not. You want them. There it is. We found it. Solution. Guess what? You just got your $1,250 earned, and it took us like, what, 15 minutes? You guys are going to rake it in someday. I promise. Really. Work is easy. So when you get there, 0.571, being a student's hard. 1.571, those are your XY solutions. They simultaneously, those are the only X and Y that you can put in both equations and get the same result. So it's the solution. Now, I don't know about you, but that's a lot of decimal going on there. So I'd love to know, what if you were stranded on a beach, warm beach island, no calculator, all you had was like a beach ball or something, volleyball. And you're sitting on the island and you had to solve this problem. Because that'd be weird. Okay, so we'll go with this. We're going to solve this thing. The other option you have is when you have two equations, to find where they intersect is where they're equal, where they're the same. An equal sign means the same. So does this sound familiar too? If you're going to solve by graphing, it's the intersection. If you're going to solve by hand, it's where the two equations are equal to each other. It's when they're equivalent. So we're going to do like 2 minus 3/4 x. And we're going to set that equal to the 1 plus x. And so that's solving by hand, is to set equal. So, and if anything comes up that you're wondering about, just let me know. But that's it. We do that. Now, we already know it's 0.571 and 1.571, but there's got to be a fraction in there somewhere, a better answer than just 0.571, and there is. So when we solve this, this is where all your combining old solving skills come in. Like you want to combine like terms, like you do opposites, subtract 2, subtract 2. Good old days. I bet, you know, you remember dropping the negative on the negative 3/4 x. That'd be a normal mistake to make. Forgetting that you're subtracting, you know, 1 minus 2 is negative 1. Just little stuff. But those algebra skills are still the meat and potatoes of upper level math. Bless you. Knowing how to get x out of this is you have to combine the x's. So I'll probably, you know, subtract through x from both sides. And there's flexibility in this. As you get better at it, you don't have to do it a certain way. So negative 3/4 take away 1 x is negative 1 3/4 x. Now this is not pretty. But let's talk about fractions for a minute, because that'd be good. So here I am, solving by hand, and I end up here. And like improper fractions and mixed numbers, remember that old stuff? You got to know how to deal with those fractions. So that's 4 times 1. Remember that old rule where you take the base times the whole number and then add the top number? So 7/4. How about that for bringing back some good stuff? So think of the algebra and its importance in this. That's negative 7/4 x. You can't solve very well with mixed numbers, so we often turn it to improper fractions. And then it comes to this one. Does anyone remember what to do now? It's tempting. If you're feeling bold, you should go for it. It's one of my favorite math operations. Maddie, you want to go for it? Yeah, you get rid of fractions. Like if you have a fraction multiplied to x, you get to multiply by the reciprocal, and it like cancels. I love that one. I don't know why it's so satisfying. Just put it in electric green because it's so fun. So negative 4/7 times both sides. But you got to be careful with things like parentheses because you don't want to think you're subtracting. You wouldn't add 7/4. Thanks, Siri. You don't want to add 7/4 because that wouldn't undo it. This is multiplied to the x, so you got to undo the fraction. It's really dividing by 7/4, but you're multiplying by the reciprocal. Fun, huh? So think of things that you want to remind yourself of. That gives you x is negative 1 times negative 4/7, which should be positive 4/7. Does that sound like 0.571 to you? Totally. It is if you look it up. So if you want to get y, though, that's only one part. That's not the solution. That's not x and y. That's just, where am I going to go get a y? Anyone have an idea? Put it in. Do you have a favorite equation? Do you want to put it in the red or the blue?
Blue.
Blue? Blue. Plug it right there. Y equals 1 plus x, and we end up with y is just 1 4/7, which is 0.571 and 1.571. Wasn't that fun? Walk down memory lane. So I'm going to give you some more to do. I got to cancel my recording here just a second.